Hello, parents and any teachers or students who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we'll look a little bit at the meaning of addition and then addition strategies. Now, these are not my meanings for addition. A lot of what I learned was from cognitively guided instruction out of the University of Wisconsin and many other sources and projects and research that was done. But if you just think about when you look at a story problem that has an addition context, the actions within that story tend to be putting together or joining or combining. Even later in algebra, they'll hear combine-like terms, right? So one meaning for addition is that joining and combining. The other is just thinking about parts that we're looking at the total of the parts, part total. Now, this helps us have language for reading symbols. If I read those symbols that I just added as 5 plus 3, that's great. It's mathematically correct, nothing wrong with it. But it's not the language your child will see in a story problem, in a word problem. If I see the symbols, but I read them as 5 joined with 3, 5 put together with 3, 5 combined with 3, you see, that helps start to build the connection between language of story problems and the symbols. So when you're working with your children at home and you see these symbols, try reading them using that language of put together, joining, combining, the language of the story problems so that they get used to that. We also use and, right? 5 and 3. Now, in terms of addition strategies, in this video, we'll look at using place value and the importance of that, bridge to a place or bridge to a whole, which actually is the associative property, and then doubles and near doubles, which gives us the foundation for the distributive property that your children will be using as they move up into the grades and into middle school, and a count-on strategy. Now, if we look at a problem like 64 plus 23, you may see your children using a part total chart. You can see the 2 parts and the total below. It's just a way that we organize what they're doing. You may also see your children using base 10 materials. Now, if you look at these, you have rods of 10 and then some unit cubes. And we use those to help them understand that when you combine 64 and 23, you have to combine the 10s with the 10s and the 1s with the 1s. And you can see that very clearly here with the size of the units. You've got to combine like size units. Now, I showed it in a very organized way, 10s and 1s. But when you use this model, nothing says you have to organize the 10s together and the 1s together. In the left-hand side, you still have 64, and in the right-hand side, you still have 23. And I can organize them however I want on the screen in the mat, right? Now, you may also see hundreds flats, 10 by 10s, or thousands cubes. All of these are to help your children get a sense of the size of the units and combining like size units. Now, when I was in school, we would have written this vertically more often than horizontally. And we spent a lot of time on alignment. You had to have the 1s places aligned, the 10s places are aligned. Now, mathematically, that's not required. What's required is combining 10s and combining 1s. But we did it because that algorithm had us treating every place as 1s place, 4 and 3, 6 and 2. Our facts were very important for that. But when I start to really understand place value, it doesn't matter where I write those numbers on the screen, on the paper, right? You know, you combine 60 with 20 and 4 with 3. We combine like size places. So alignment is not as critical when you understand place value. And I mentioned before that combining like size units, like size places, is foundational for combining like terms in algebra. Now, you may see your children also using partial sums, it will be called. And that's really a place value approach. I combine 1s with 1s and I record what that answer would be. I combine 10s with 10s, hundreds with hundreds, thousands with thousands, and you just see the result of combining each of those places, and then we combine those to get our total. You may see it written where the child works left to right. See, when you're using a place value approach and partial sums, you aren't required to work right to left. You're maintaining the place values. Now, again, it's combining like size units, and this becomes important when your children get to mixed number addition in 4th and 5th grade. See, when I want to combine 3/4 and 1/8, I need like size units. Now, this drawing is linked to fraction kits. Your children will probably work with fraction kits when they start working with fractions. This links to a construction paper version that I have. And so you can see I've got 2 wholes and 3 1/4 pieces, and I'm combining it with 3 wholes and a 1/8 piece. So seeing this visual model, I know I combine wholes with wholes and parts with parts. But right now, I can't combine that 1/8 piece with the 3 1/4 pieces because they have to be the same size. Now, we learn get the common denominator. We learn things about least common multiples in school. But what we were doing was finding the same size fraction piece and putting each of our parts into those same size pieces so that we can combine them. In this case, we'd want to rethink about 3/4 as 6/8, but see, we're getting like size units. So there's more to it conceptually than least common multiples and common denominators. And these models help your children see and reinforce combined like size units. Same will be true when they do decimal addition, right? We combine wholes with wholes, tenths with tenths, hundredths with hundredths, thousands with thousands, like size units. Now, those examples I gave you, there was no regrouping needed, right? We didn't have to worry about bridging across to 10. But in this problem, 38 plus 25, typically we're going to have to regroup. Now, again, when I was a kid, we wrote it vertically. We'd have 8 and 5. And think about if I have 13 ones, I need to rethink about it as 1, 10, and 3 ones. That's why we wrote the 3. And when I was in school, we called it carrying the 1, right? There was a very symbol procedure that we were using. And now you'll hear regrouping. That's that rethinking of it as 10s and 1s. So we're going to rewrite that 1 as a 110. So we had that procedure, right? But there are other strategies we can use that take what was required to be paper and pencil for many of us into what can be mental arithmetic. And we do it, mental strategies, I guess. We do it with the models we choose. So this is a 10-frame model, and you may see your children using the 10-frame model. And so let's say I just want to look at 8 and 5 in grade 1. I put 8 of the same color in the 10 frame and 5 of a different color. And even the use of color is purposeful to help your children see what we're doing. But see, what can I do here? I can slide those 2 1s in and fill the frame. I've got 10 and 3. 8 and 5 is the same as 10 and 3. And I have many parents say, but my child already knows 8 plus 5 is 13. Why are they spending any time on this? Well, I hope you'll see what we're doing here is we're thinking of 5 as 2 and 3. And instead of associating the 2 with the 3, we're going to associate the 2 with the 8. See, your child knowing 8 plus 5 is 13 fluently, immediately, is important. It's helpful to know your facts, but this is the imagery for the associative property. So we're wanting them to spend time with this also, not in place of knowing facts, but in addition to, because it is the associative property. And that's a property that will work right up through the grades for your children. So I associate it. I have 10 and 3. Okay. Now, I can work with larger numbers. When your child gets to grade 2, they might see some of these images to start. What's 28 and 25? Well, I can think of 25 as 3 and 22. Instead of associating the 3 with the 25, with the 22, I associate it with the 27. So that's the same as 30 and 22, a mental arithmetic problem. I can do that mentally, no paper and pencils required. If I use this strategy for 27 and 25, I can also use it for 298 and 372. What's that the same as? 300 plus 370, 670, done. I know the answer and the time it would take someone to write it down on paper, right? So great strategy, very efficient, very effective for most students. And look at this mixed number problem. See, I can associate a 1/4 piece in either direction. I can think of this as 6 plus 3 2/4, or I can think of it as 5 2/4 plus 4. Either way, I'm going to get the same answer, right? 9 2/4. So that associative property will work for mixed numbers. It will work for decimal numbers. This is essentially the same problem as I had on the second line, right? 2 98/100 is the same, and plus 3 72/100 is the same as 3 plus 3 7/10 or 3 70/100. Now, do you notice how I'm not reading that with point? 2.98, 3.72. When we want your child to write the number or enter it in a calculator, we might use the word point, but that does not help with place value. So when you're working with decimals with your children, please read them using place value terminology. 2 98/100, 3 72/100. It helps us with place value. It helps us with size of units, right? Which combining like size pieces, vital for what we're doing. Now, doubling is another strategy, and I'm going to go back to the part total chart, and I can show you 34 doubled. But notice how this is represented as double 30 and double 4. I can look at this also multiplication, right? So if your child's in grade 2, they'll see the addition version. As they move into grades 3 and 4, they'll see the multiplication version. But think about what this model sets up. What did I do? I doubled 30 and I doubled 4. Mathematically, at this point, parentheses aren't needed. That's order of operations. But your child is hearing double 30 and double 4 and seeing it written something like you see below in your screen. The thing with this is that's the distributive property. I'm thinking of 34 as 30 and 4, and I'm also thinking in terms of place value. That's expanded form for 34, 30 plus 4. I double the 30, I double the 4. Foundational for distributive property. Now, in grade 1, you may see a model like this, a 5-frame model, essentially half of the 10-frame. It's a great model because it lets us look at numbers between 5 and 10 in relation to 5. Here's 8 in relation to 5, 3 more than 5. When it comes to doubling, this is a really clean image, nice image, and it also sets up the foundation for distributive property. What do I have? Double 5 and double 3. It helps your children with this foundation in grade 1 build what they're going to be asked to do in grade 3 with multiplication. Because see, what do? Those 5 frames come together to make the 10. So we're wanting them comfortable with 5 and 10 frames, but you see, we don't want to think of 5. That 5 frame is only something we use in pre-K or in K, but once they get to grade 1, they have to go up to the 10 frame. See, we're picking the model purposefully because it helps build the foundation again for distributive property. It lets them double the 5 and double the 3 to get 16. Now, you'll also hear near doubles. The idea is if I know double 8 is 16, then what's 8 and 9? It's a double plus 1. And you see how we're using color to highlight that extra 1. Now, I can use doubling for double 39. Paper and pencil is not required. You may already have been thinking, oh, that's double 40 minus 2. See, how am I thinking of 39 in this case? As 40 minus 1. What did I do? To double 39, I'm doubling 40 and removing 2. Distributive property again. If I use it for double 39, I could use it for double 298, right? What do? Double 300 minus 4. And if I can use it for double 298, I can surely use it for double 2 98/100. Double 3 minus double 400. Now, another strategy is a count-on strategy. And for me, I usually have children only count on 1, 2, or 3. There are other strategies that become more efficient if we want to try to count on more. But where counting on 1, 2, or 3 is really helpful is right around transitions for decade numbers, the tens, century numbers, the hundreds, right? We get up into the thousands, going back and forth around those key units. It's very helpful to be able to count on and count back. See, I can count on 2 to 39 to get to 41. I can count on 3 to 298 to get to the 301. Much more efficient than paper and pencil, allows me to use the mental strategy. Same idea. If I'm going to count on 1, 2, 3, I could count on 10, 20, 30. I could count on 100, 200, 300, right? I have 386. I can count on, so I have 396, 406, 416. Now, I hope that gives you an overview of addition strategies you may be seeing your children use. I hope that explains why the place value focus is so important, because it's setting up that foundation for combining like terms and removes that requirement for alignment. Like I said, we focused a lot on alignment in school, even turned notebook paper sideways so all the columns align, but not mathematically required, as long as your child combines like terms. Now you see the doubles, that gives us that foundation if we use the right model for distributive property. So instead of your child learning purely arithmetic approaches to computation, we're using more algebraic approaches. And that's why, even though they know 8 plus 5 is 13 immediately, I hope you see why we're having them use the materials and actually draw the pictures and spend time on that imagery for the associative property. And as I said, the count on works great. Count back later, if I have 301 and we want to remove 3, count back 3. If this video was helpful, I hope you'll give it a thumbs up. Please subscribe to the channel. Click the bell for notifications so you know when future videos are coming. And thanks so much for watching. There'll be future videos that are grade level specific examples that you may find helpful for your children.